Guys, it's Sam again. So in this video is the continuation of the previous one about rate of change. Here I'm actually going to explain the derivative. This is going to be the definition of the derivative, where it comes from. Most people know how to use it, but students, I'm talking about students, but they don't know, very few know exactly where it comes from. So it's nothing more than what we did previously, but just pushing things a bit further. Now let's consider we have a function that is not linear, like this one, f of x equals x squared. Okay, so a second degree function or quadratic function. And let's say we draw a secant to this. Now, if I want to take the rate of change of the function at any point, this secant doesn't really allow me to do that. It gives me the rate of change, the average rate of change between these 2 points, this point here and this one. If I make it, if I bring it closer, if I bring the second point closer to the first one, then it gives me a rate of change that is the average between these 2 points. And let's call this difference delta x, okay? And the first point here would have coordinates x1, y1, and the second point would be obviously x2, y2, okay? Point 1 and point 2. Now, between x1 and x2, we have delta x distance. Imagine what would happen if delta x becomes smaller and smaller. And as a limit, we could imagine that delta x as a limit would go to 0. What would that give us? It would give us actually a tangent line. Okay, let's say this is point 1, then we would have really a tangent line to this point. So if the distance between x1 and x2 is 0 at the limit, we would have no longer a secant but a tangent, and the function would be the same. Now remember that to take the rate of change, what we do is y2 minus y1 divided by x2 minus x1. Okay, so let's do this. This is x1, y1, and this here in terms of x1, instead of putting x2, let's put x1 plus delta x, right? Okay, and the y point would be f of, so function of, what's the y value when the x is x1 plus delta x. So the coordinates here that we're going to use are actually x1 plus delta x and f of x1 plus delta x. Okay, so let's now apply y2 minus y1 over x2 minus x1. What we would have, y2 is no longer y2 but rather f of x1 plus delta x minus what? Minus this here, right? So y2 minus y1, and then we would have y1 over divided by x2, which is x1 plus delta x minus x1. So it's x1 plus delta x minus x1. Look what happens. x1 minus x1, they cancel out. And what we would have here is limit. I'm actually going to have to continue this in the next video. So limit x goes to 0. See you in the next video.